Remember back in school when you learned about the states of matter? You had your solids, your liquids, and your gases. If you're lucky, you even got to plasma. But what if I told you there's a fifth one that's so incredibly strange it completely shatters our everyday idea of how the world is supposed to work? So let's just dive right in. Way beyond those familiar states of matter, there's something else. And it's not just another flavor of the ones we know. It is a completely different ballgame, run by the totally weird and wonderful rules of quantum physics. So, what is this mysterious fifth state? Well, it's called a Bose-Einstein Condensate. And the key to making one, the secret sauce, is to get a bunch of particles incredibly, unbelievably cold. I'm talking colder than the deepest parts of space, colder than anything you can really wrap your head around. So, in a Bose-Einstein Condensate, or a BEC for short, something amazing happens. All the individual particles, they kind of lose their identity. They stop being a crowd of separate things and start acting together, in perfect sync, almost like a single, giant superparticle. And look, when I say cold, I don't mean stick it in the freezer cold. We are talking about cooling matter down to just tiny fractions of a degree above absolute zero. That's 0 on the Kelvin scale. It's the theoretical temperature where all the jiggling and vibrating of atoms pretty much just stops. All right, so how on earth does getting something super, super cold make all its particles act like one big thing? Well, to get our heads around this, we have to just leave our normal, everyday world behind for a minute and take a trip into the quantum realm. Okay, this next part. This is the one idea you absolutely have to accept for the rest of this to make any sense at all. At the tiniest quantum level, every single thing we think of as a solid little particle, like an atom, also behaves like a wave that's spread out in space. It's weird, I know, but it's just a fundamental rule of how the universe works. You know, our intuition, our common sense, it's built for the classical world, for things we can see and touch. It evolved to help us survive, right? To not get eaten by a lion. It was never designed to make sense of the quantum world, which just plays by a completely different rulebook. So for the next few minutes, let's just agree to put that intuition on pause. So here's how it works. When particles are hot, they're just buzzing around like crazy, and their little quantum waves are short and tight. But as you start to cool them down, they slow down. And as they slow down, their waves start to get longer and longer, and then really, really long. And this is where the magic happens. As you get impossibly close to absolute zero, those waves become so gigantic that something incredible takes place. We hit the moment of condensation, the moment they all become one. The waves from each individual particle stretch out so far that they actually start to overlap with the waves of all their neighbors. They're not separate little things anymore. They're all mixed up together. It is exactly like that old cartoon, Voltron, where you had 5 separate lion robots that would all come together to form one giant, super powerful robot. These particles merge their quantum identities into a single entity. They literally become the Voltron of particles. And that is what we mean by a metaparticle. All those separate waves are now overlapping and vibrating together in perfect harmony. They're not just a group anymore. They are a single, coordinated quantum system. Now, as bizarre as all this sounds, it's really just a phase change. It's no more fundamentally strange than watching a clear liquid, like water, suddenly turn into a hard white solid when you drop the temperature. It's just a phase of matter our senses weren't built to see. Okay, so we made this quantum superparticle. Cool, but what's the point? Well, it turns out that when matter starts behaving this way as one single thing, it develops some truly astonishing abilities. You could even call them quantum superpowers. Yeah, this quantum hive mind behavior leads to incredible things like superfluidity, where a liquid can flow with absolutely zero friction. It would climb up the walls of its container. Or superconductivity, where electricity can move through a material with zero resistance forever. This is the tech behind things like MRI machines and those futuristic maglev trains. So the potential here is just mind-blowing. But there's a catch, right? There's always a catch. The single biggest hurdle is just how ridiculously hard it is to create and maintain these extreme temperatures. It's a massive engineering challenge, and figuring out how to do this stuff at even slightly warmer temperatures is one of the biggest goals in physics today.
So the big takeaway from all of this is that you can't really force the quantum world to make sense in the way that a falling apple makes sense. Our normal questions don't really apply. Instead, you just have to kind of get used to it. You have to accept its strange and wonderful rules. It doesn't have to make sense. It just is.
And that leaves us with a final, pretty wild thought. The only reason we didn't know about this fundamental state of matter for almost all of human history is that our senses just can't detect it. And it really makes you wonder, if our entire reality is being filtered through such a limited toolkit, what other huge fundamental parts of the universe are we completely blind to?